This is the Seiko UC2200, and it's the base unit for a Seiko smartwatch from the I think it was 80s or 90s. And you plug your watch in here, and there's an inductive link between this base unit and the watch. The interesting thing is there's a printer over here, and there's an application ROM pack here, and within the unit there's a Z80 processor, and this keyboard is mainly there so that you can type basic programs into the base unit, and also enter memos into the watch. I bought this because I wanted to dump the ROM. I got a watch with it, but it doesn't work, and I bought a second unit, a 2100 or a 2000, can't remember, and that didn't work either. But anyway, the object of the exercise was to dump the ROM. And if you have a look inside, this one has been dismantled, the board has come out and so on. There's a Z80 processor in a flat pack there. There's an ASIC type device here, which I think is driving various things. There's some RAM over here, and that is the ROM, or it was, because it's gone. It's in a 44-pin quad flat pack, but it's a 1mm pitch, which is an odd pitch, and I couldn't find a footprint for it, and I couldn't find a data sheet for it. The part number is SMM2326, and so what I did was take it off, and I thought about wiring some wires to a Pico and running a ROM dump that way, but decided not to do that because there's a lot of wires, and with those falling off all the time and the actual effort of wiring it up, thought it was easier just to make a PCB. So this is a footprint I made for a 1mm 44-pin quad flat pack attached to a Pico. There's some jumper stuff going on here because the pin out of this, I didn't have a data sheet, so what I did was beep out the well, whatever pins I could over to the Z80. There is a data sheet for that, so I could work out roughly where the address and data lines were, and chip select and so on. And when I looked at it, it's actually a 28-pin JEDEC pin out, but just sort of going round the 44-pin package. There's quite a lot of unconnected signals on this, quite a lot of pins that don't have any signals on them. So I could actually infer what the signals that I didn't know the function of, things that went to the ASIC and so on, from the JEDEC pinout, which meant that I had a pretty good idea what the footprint was. So I added that. I made a symbol for this footprint so I could wire it all up and so on. And then for code I used the postal ROM reader circuit, which didn't have enough address lines. This is a 32K EEPROM here, so I added a couple of extra lines and altered the code slightly. But that then I then tried dumping the ROM, and it didn't work, which was a bit of a surprise actually. So I thought maybe I damaged it somehow, or it was broken. I didn't think it was broken because I could get some sense out of this base unit. It did say transmission error, which is the only thing it says when you can't talk to the watch. So I knew it was probably okay. And it turns out that this ROM, unlike I think any other ROM that I've seen, actually requires an edge on the well, on the line that was going to read on the Z80, which I suspect is probably a chip enable, or maybe a read line, but I mean ROMs don't have a read line because you can't write to them. But anyway, it required an edge on one of the select lines, which is a bit unusual, so I changed the code to create an edge, and I've managed to dump the ROM. So yeah, quite interesting, but it was easier really, in terms of effort anyway, to just have a PCB made rather than wiring it up. As I've done in the past, I've wired various chips up, sort of point-to-point wiring, but yeah, the only downside is I've now got 5 of these. I don't really want to dump any more chips in that package, but there we go.